Okay, guys, we're in Advanced Math Trig, Mod 7. Today is Friday. All right, Friday the 17th. So in the top left corner of today's notes, go ahead and put 4/17/20, Friday the 17th. The title says Graphing Exponential Functions. The key word of the new unit, which, yes, we're starting a brand new chapter or unit today on exponents and logarithms. Okay, so for the next several days, we're going to deal with equations, functions, and expressions involving exponents, missing exponents, and logarithms. Remember, logs, you were introduced to them last year, and they always start that unit or that chapter by having you graph what are called exponential functions. Pretty easy day today. If you look at all four of the problems we're about to do, y equals 3 to the x, y equals 1/2 to the x, y equals 4 raised to the x minus 2, and y equals 2 raised to the negative x minus 1. Obviously, since they all have y equals, y equals, y equals, y equals, they're all functions, and we're going to graph some functions here. Oh, well, if I said play detective and tell me what all four of these functions have in common, it's pretty obvious. They all have missing exponents. There's an x somewhere up in the exponent. So they're called, of course, exponential functions. So simple day today to end our week. We're going to just graph these four functions, and you'll try four functions to graph on your own. Okay? Now, watch how simple the approach is. Okay? If we focus on block number 1 here, y equals 3 to the x power. Guys, on all four of these, every time you're graphing an exponential function, you're making an xy table off to the side. And that table only needs to be big enough to fit 3 numbers, okay? So as I go and look at this function, and I'm trying to decide, I wonder what 3 numbers I should plug in for x. Technically, you're allowed to plug any 3 numbers you want to in for that letter x, because no matter what 3 numbers you plug in, if you correctly find all 3 y coordinates, you'll create a curve that's going to be the correct answer. However, let's use common sense here. Since x is my missing exponent, wouldn't you want these 3 x values to be small numbers and easy to work with? Right? I sure don't want to plug in numbers like, I'm just going to make up 3 numbers here. 3, 7, and 13. What's 3 to the 7th? Ew. What's 3 to the 13th? Why create huge, ridiculous numbers when we could work with numbers as small as possible? So my advice, and yes, you have to pick 3 numbers. You can never just pick 2 numbers and plug them in, because 2 dots will always look like a line, won't they? You have to have a 3rd number to justify or to see the steepness of the curve we're about to create. So guys, the 3 best numbers to plug in when that's just a plain old x up there are the exponents -1, 0, and 1. Okay? Because they're nice, small, easy to work with numbers. Plus your chart is nice and balanced now. You've got a negative, you've got a 0, and you've got a positive value. My advice, start with the 1 and kind of work your way up, because it's such an easy number to plug in and work with. Think about it. If I take 1 and I go plug it in for that x, what's 3 to the 1st power? Obviously, that'd be 3, wouldn't it? Now take 0 and go plug it in for x. I would have 3 to the 0 power. Careful, do not write 0. Any number, if you raise it to the 0 power, you actually get 1 for the answer. Anything to the 0 power is 1. Got it? No matter what the base is. And careful here, when I plug -1 in for x, this would say 3 to the -1st power. 3 to the -1st is not -3. Remember, the rule on a negative exponent is what? Pretend the negative's not there for a second. If that just said 3 to the first power, isn't 3 to the first power 3? Oh, but since it's a negative exponent, it takes that answer and flips it over and gives me 1/3 for the answer. Even if I would have plugged in -2, and that would have said 3 to the -2nd, isn't 3 to the 2nd 9th? So 3 to the -2nd would have been 1/9. So a negative exponent doesn't create a negative answer. It creates a fractional answer because the rule is to flip it over. So guys, with those three numbers now at my fingertips, if I just go 3 in each direction here, I'm just trying to sketch a nice simple graph that's going to mimic the curve I'm creating here. If I plot those 3 ordered pairs, okay, watch how easy. I'm going to go left 1, up only 1/3, right 0, and up 1. So far it looks like a line, but right 1 and up 3. You can see the turn that the curve takes. I'm going to go through that dot, and it steeply goes upwards. Now, what happens over here, guys? Careful. Remember I said if I would have gone left 2, I would have been up 1/9. Left 3 would be up 1/27th. Left 4 would be up 1/81st. Guys, that curve will never, ever cross the x-axis. So when you draw your picture, get close to the x-axis, but don't touch it. It's called a horizontal asymptote. And the curve looks like that. Okay? All right, now that we got the idea, go to number 2. Make an xy table. I have an exponential function. Plain old x is my exponent. You want the exponent to be -1, 0, and 1. Let's plug 1 in. What's 1/2 to the first power? Obviously 1/2. Let's plug 0 in. What's 1/2 to the 0 power? Anything to the 0 power is 1. Let's plug -1 in. 1/2 to the -1st. Okay, careful. If that just said 1/2 to the first, the answer would be 1/2. But because it's a negative power, we're flipping it and getting 2. So guys, on my picture this time, let's just go a couple in each direction. Nice and neat here. We're going to go left 1 and up 2, right 0 and up 1, right 1, but only up 1/2. If I would have gone 2 and plugged a 2 in, wouldn't 1/2 squared be 1/2 times 1/2, which would be up 1/4? Again, kind of proving to me that this curve gets really close to the x-axis but doesn't touch it, and it takes a pretty steep turn upwards and looks like that. So it's not as steep as the other one because the numbers aren't growing as largely as quickly, but they always take on a curved shape when you graph an exponential function. All right, number 3. Now careful here. Guys, think with me. Ready? You do not plug in -1, 0, and 1 on this one. I didn't say those are the 3 numbers you always plug in. I said those are the 3 numbers that you want your exponent to be. So since that was just a plain old x in number 1, and that was just a plain old x, yes, we chose -1, 0, and 1 because that's what you want the exponent to end up being. So guys, if we look at this problem here, my exponent is x minus 2. I want that exponent to end up being -1, 0, and 1. So I'll give you a minute to think about this. What 3 numbers would you plug in if you want that exponent to turn into a -1, then turn into a 0, and then turn into a 1? Well, let's think about it. Wouldn't it be 1, 2, and 3? Okay, let's think. Watch. If I take 1 and go plug it in for x, what's 1 minus 2? It would be -1, wouldn't it? Plug 2 in for x. What would 2 minus 2 be? It would be 0. Plug 3 in for x. What's 3 minus 2? 1. So you want to create the exponents of -1, 0, and 1. So let's go backwards just like we've been doing. If I take 3 and plug it in for x, 3 minus 2 is 1. 4 to the first is 4. Just simple math calculations, all right? Plug 2 in. What's 2 minus 2? 0. Anything to the 0 power is 1. Finally, plug 1 in for x. 1 minus 2 would be what? Negative 1. 4 to the negative first would be what? Flip it over. 1/4. So it works out fine. I better go 4 in each direction this time. Have enough room on your graph. I'm going to go right 1, up just 1/4, right 2, up 1, right 3, but up 4. So everything's kind of been shoved over a little bit. Do you agree? I'm going to go through that dot and through that dot, and once again, get close to the x-axis, but never touch it. Okay? So my y-intercept's actually less than 1 this time. And finally, the last one. Nice short day today. XY table. Again, look at your exponent. If it's just an x, you'd go negative 1, 0, and 1. Since it's not just an x, we got to think what number would create negative 1, what number would create 0, and what number would create a 1. Oh, boy. Well, guys, if I want to create negative 1 as my first exponent, wouldn't I plug 0 in? Because think about it. If I plug 0 in for x, you with me? 0 minus 1 would be the negative 1 we were trying to create. Now what number would I plug in? Oh boy. Now remember, I want my exponent to end up being a 0. So if that's a negative 1, don't I want what's under my finger to end up being a plus 1? So wouldn't I plug in negative 1? You got to be a little bit creative here. Because think about it. If I plug negative 1 in, I've got negative 1, which is 1, and 1 minus 1 gives me 0. Oh, so guys, negative 1's the next number, and then wouldn't negative 2 be the third number? You kind of get a pattern going, because negative 2 would be 2, minus 1 would be 1. And we know 2 to the first power is 2. When we plug negative 1 in, we created a power of 0, meaning my y-coordinate's 1. Plug 0 in for x, I'd have 0 minus 1, which is negative 1. And 2 to the negative first is 1/2. So interestingly, for the first time today, if I plot these numbers, I'll just go a couple in each direction. Right 0, up 1/2. Left 1, up 1. Left 2, up 2. What's happening here is for the first time, it looks like my function is going downhill. That happened up here on the fractional one also, my fault. But it's a downward exponential function, kind of exponential decay, because it's sloping at a downward angle because of the negative x that was up there. So guys, graphing exponential functions, you're making a table, plugging in 3 numbers, and just kind of calmly thinking your way through your 3 ordered pairs, plotting your points, and creating a curved shape. When you get to calculus next year, if you do, they can take this function and rotate it and spin it around either axis they want and create all kinds of cool 3-dimensional pictures to design and create things like that. So you got to know the basics of graphing and attacking an exponential function. Okay? Your homework, flip to the back. Well, I'm going to flip to the back. Your homework for today, Friday the 17th. It'd be great if you're watching this video on Friday like you're supposed to. Why not get these 4 functions done? It's fresh in your mind. Turn it in. Send me a picture of them. And you're all done for the weekend and don't have to worry about any math for the weekend. However, since it's Friday the 17th, technically, this is homework for tonight, like an assignment. So technically, I don't have to have this till Monday the 20th at noon. Some of you are starting to turn things in late. This is not something we're doing at your convenience. Guys, I've got 111 kids to keep track of for all the homeworks coming to me every day. Please get a routine and turn things in on time. All right, so real quick, you can pause the video here, copy down these 4 problems: 2 to the x, 1/3 to the negative x, 3 to the x plus 2, and 4 to the x minus 1. Take your time, graph those 4 functions nice and neat. And good luck with that. Great job this week. We'll pick up with this chapter, introducing you to logarithms on Monday the 20th. Have a great weekend. See you on Monday.